Hi students, today we're going to be doing place value, but instead of being to the left of the decimal place where we were talking about ones, hundreds, thousands, 10,000s, 100,000s like we did in the previous lesson, today we're actually going to be talking about tenths, hundredths. Oh, so you know that we're now to the right of the decimal point, right? So tenths, hundredths, then thousandths, 10,000ths, and 100,000ths. Okay, so let's go ahead and take a look at some of these. Now, what we're going to do is I'm actually going to show you pi, okay? And you're like, ooh, yes, that sounds so good, right? In fact, don't just show me pi, give me some pie because that sounds delicious. No, I'm not talking about that kind of pie. I'm talking about when you divide, right, the circumference and the diameter that you get pi, this mathematical concept of pi, right? It's sort of a really, really long digit. You've probably heard the 8th graders, 7th graders, 6th graders, they have memorized many of the digits in pi for Pi Day that is on March 14th, right? Well, Pi Day, that's sort of interesting. Well, March 14th, what's the date of that? Well, it's 314, right? And it's because pi is sort of reduced down to 3.14. Now, when I said point, what do I mean by that? Well, that point that I said was a decimal place, right? So we have 3 in the ones place, and then we have 1 in the tenths place, and a 4 in the hundredths place. Now, you're noticing that I'm not saying tens or hundreds, but I'm saying ths, right? T-H-S, right? Tenths, hundredths, thousandths, right? And so on and so forth. Well, let me show you pi. You can look at the screen next to me so that you guys can see what I'm doing. But we're just going to start here with pi, and I want to show you at least 5 digits, okay? I'm going to show you 5 digits that are to the right of the decimal point, for the number pi. So you'll see here, right, I've actually got a circle, and you might be wondering, what is a circumference? What is a diameter? Don't worry about that. You'll get there. We'll talk about pi at a later time, but I just want you to know that you can even see my diagram, right? The surrounding of a circle, right? The distance around a circle is called the circumference, okay? And then the distance from the middle, right? If you sort of cut, right, the circle in half, right? The distance from point to point, right? In the circle, sort of the midpoint, right, is known as the diameter, okay? And so if the diameter is 1, okay, and the circumference, right, would then be 3.14, right? And so 3.14 divided by 1 is 3.14. Okay, so pi is 3.14, and you're like, what does that even mean? Don't worry about it. I just wanted to use it because it has a decimal. Okay, so the first thing that we're going to look at, we look at this first 3 here, which is 3 ones. Very good. 3 ones. Now, the next number that we're going to look at, right, is a 1. And normally you would look at the 1 and you would say, oh, 1 whole, right? Well, actually, no. That decimal point is actually now saying we don't actually have a whole. Now we have a fraction of the whole. So everything to the right of the decimal place is actually going to be a fraction of 1, 1. Wow, interesting. So everything to the right of the decimal point is going to be a fraction of 1, 1. All right, so let me explain what I mean by that. Okay, if we look here at 3.1, okay, we have a 3 in the ones place, okay, and a 1 in the tenths place. Okay, a 3 in the ones place and a 1 in the tenths place. So this number is made up of 2, right, place values, right? We have a 3, we have 3 ones, and, ooh, very interesting, 1/10. 1/10. So we would actually, if somebody said, what is 3.1? You would actually say that is 3 ones and 1/10. Okay? All right. So if it were dollars, for example, it would be $3.10. All right? $3.10, or $3.01 of a dollar. Okay? So remember that everything to the right of that decimal place is a fraction. Okay? So what about this one right here? Well, there's a few different things that it's made up of. 3.14. And this is actually the way that pi is most typically expressed, is 3.14. But we have 3 ones. We have 1/10. And we have 4 hundredths. Okay, 4 hundredths. So we have 3 ones, 1/10, and 4 hundredths. Interesting. Okay, that's very, very interesting. Well, when we think about this place value, it's a tenth, and this is a hundredth. Now you might be saying, where's the oneths? Well, there's no oneths, right? It's tenths, hundredths. Okay, so the 4 is in the hundredths place, and the 10 is in the tenths place. And so the reason why it's hundredths, though, is if you think about it with the dollar, right? Well, let's say we have $3.14. We have $3.14 1/100ths of $1, right? Or of 1 that's in the ones place, okay? 1, 1. All right, so when we think about 3.14, we have 3 whole, okay? When we have 14 100ths. All right, very good. All right, now let's look at the next one. We have 3 ones, 1/10, 4 hundredths, and then we have 1,000th. One thousandth. All right, so when we look at this one, it's in the tenths place, the 4 is in the hundredths place, and the 1 is in the thousandths place. So I have 3 whole, but then I have 141 thousandths, right? You hear that? 141 thousandths. Right? So that means, okay, all right, that I do not have a whole, right? That 141 thousandths, that's a fraction of the whole, okay? All right, now let's look at the next one. All right, now this 1, I'm not going to break it apart like the other ones, you're getting the idea, right? So the 1, again, is in the tenths, 4 is in the hundredths, 1 is in the thousandths, and then this 5 is in the 5 is in the 10,000ths, okay? So the 5 is in the 10,000ths. So we have 1/10, well really we have 3 ones, 1/10, 4 hundredths, 1,000th, and 5 10,000ths. Okay, well what about this last one here? Well, we've got 3 ones again. We have 1/10, 4 hundredths, 1,000th, 5 10,000ths, and then what about this 9 then? This 9 is 9 hundred thousandths. So I have 3 whole, but then I have 14,159 what? Out of 100,000. Right? Okay. All right. Very good. So when we're thinking about the ones to the left of the decimal, yes, but once we get to the right, remember it starts as tenths, hundredths, thousandths, 10,000ths, 100,000ths. Okay. Awesome. All right. Let's look at a couple here. Let's look at number 1, which is 13.1. So the thing I want to show you really quick as we're working on these is I want to show you a number line. Okay. Now, what are the 2 numbers, whole numbers, very important, the word that I just used there. What are the 2 whole numbers that 13.1 is in between? Remember 13 ones, right? 110, 3 ones is 13 ones, obviously, but then 13, right, is on the left of the decimal. So those are whole. This is a whole number that we're talking about, 13. Okay, but what about the parts, right? Or this, not the parts, excuse me, but what about the nths, right? Well, there's 1/10. Okay, 1/10. So we're in between 13 and 14. 13 and 14. Okay? All right, very good. All right, so where is 13.1 on this number line? It's interesting. Okay, well, we have, let's see, could we make each notch here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what if we did, why don't I fix this? Might as well make it exact. Okay. So this is 13, this is 14, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, I shouldn't have erased that. Forgive me, it's still early in the morning. Okay, that is, there we go. Okay, so this would be 13.1, 13.2, 13.3, 13.4, 13.5, so this is our midpoint, 13.6, 13.7, 13.8, 13.9, and then we would get to 14. So we know that 13.1 is right here, closer to 13, right? So it's 13.1, right? Or 13.1, so 1/10, 3 ones, and then 1/10. Is that closer to 13 or 14? Well, it's closer to 13, okay? All right, now 13.9 would be closer to 14 than 13. All right, well, what about 13.15 or 13 ones and 15 hundredths? What about that? Well, same thing here that I can do, all right, is I can think about this in between 13 and 14. But this time, each notch, what I'm going to do is I'm going to make these each one is 13.10, or is 0.10, okay? So 10 hundredths. So it's 13.10, 13.20, and then so on and so forth until I get to 13.50, right? And this is then 14. So this would be 13.70, right? So you get the point of our number line here. 13.80, 13.90, and then 14. Okay, so this would be 13.30, and this would be 13.40. So you're kind of catching on to our number line. Well, where'd 13.15 be? Well, it would be right here, right? So it'd actually be closer to 13 than 14, okay? All right, well, what about 13.159? Well, if we looked at the same one, right, it would be almost in the exact same spot, right? It's almost in the exact same spot. Same thing with 13.1594. The point is that we're trying to recognize that the further we go, right, whether it's tenths, hundredths, thousandths, 10,000ths, 100,000ths, the further we go, right, the smaller, in a sense, right, that we're looking at this, right? Because if you even think about, or let me rephrase that because that didn't make sense. I apologize. What I mean is as you're going in your decimal points, right, the further out you're going, the better understanding you have of your number, right, and where it is on the number line, right? Now, sometimes it stops, right, and doesn't go as far as, like pi does, 3.14, that has loads of different digits, okay? But the point is that I'm really trying to show, we're actually not going to do 3 and 4, but you can notice from 3, 4, and 5, right? Like if I were to look at the 1 that's in the tenths, the 5 is the hundredths, the 9 is in the excuse me. The 1 is in the tenths, the 5 is in the hundredths, the 9 is in the thousandths. Okay, here there's a 4 that adds on, that's the 10,000ths, and then this 3 here that's added on in number 5, this is the 100,000ths, right? So I really just wanted you to see those. And that the numbers really can go that far out, right? But one of the things that you'll recognize is that you actually can round these numbers to the nearest place value. So if I, for example, took 13.15943, okay, and I probably, if you owed me, for example, let's say that you borrowed $13 from me, but you borrowed $13 and let's say you borrowed this exact number, right? You couldn't do that necessarily with change, but when you think about it, if this is what you borrowed from me, I'm probably not going to make you do that, right? As I'm doing I'm not going to make you go all the way. That would be very difficult, right? Almost impossible, unless we had a bank account where we were able to break it apart like that. But for example, on the taxes, right? If I were doing taxes, which you have to do every year because it's a law, but if I'm doing taxes, right, it's possible that I'm going to get a number like this. However, I'm not going to put this number in my tax form. Rather, what they say is they say round to the nearest place value. Okay, so for 13.15943, I would round to the nearest 10th place. Now, for this one, number one, it says to the nearest 100th place. Well, I need to find my 100th place. So that would be right here, the 5. So the 5 is in the 100th place. So I'm going to round to the nearest 100th place, which would be that 5. So I look at the number next to it, which is a 9, which means I'm going to round up. So then I round this to 13.16. And therefore, I don't have to keep going. And then I could just say, I owe you $13.16, right? Be a lot easier. Same thing, this says now to the nearest 10,000th place. Well, let me find the 10,000th place. Well, the 1 is in the tenths, 5 is in the hundredths, 9 is in the thousandths, 4 is in the 10,000ths, okay? All right, so I'm gonna look at the number next to it. It's a 3, so I'm gonna stay at 4, right? So it's gonna be 13.1594. And then I stop instead of going on, because some numbers could take you a very, very long time. So that's sort of the idea of rounding to the nearest place value. Okay? All right, cool. Well done. The big idea for you guys to get from this lesson is really just that we have these additional place values, because you guys are going to be talking about those in 4th grade. Okay? All right. Well done. Talk to you later.